Hi students, this is Mr. Yang. In this lesson, we're going to continue to learn more about triangles. More specifically, we are going to review and learn more about isosceles triangle and equilateral triangles. First, the definition. Isosceles triangle. Triangle is isosceles if it has at least two congruent sides. So it says at least because you can actually have three congruent sides. That is just a special case of isosceles triangle, which is an equilateral triangle. So for here, specifically isosceles triangle, two congruent sides are called the legs. As you can see on the right side, the left and the right, they're the legs. The third side is called the base. The angles formed by the legs is the vertex angle. So right here on the top, the two legs and this other point together, that is the vertex angle. And the two angles adjacent to the base are called base angles. So this is the base angle, this is the base angle. Now let's move on to talk about some theorems that come from the isosceles triangle. Isosceles triangle theorem. If two sides of a triangle are congruent, so the first part, the if two sides, so side AC and side BC are congruent, this is the congruent symbol that you have learned last year in congruent triangles. It's the equal sign with a little squiggly line on the top indicating congruent. So if AC and BC, the two sides are congruent, then the angle opposite those sides are congruent. So opposite of AC is angle B, opposite of BC is angle A, so that's why we can conclude that angle A and angle B are congruent as well. So the isosceles triangle theorem in short is basically if you know the sides are the same, you can conclude that the angles are the same. Then we have another one, which is called converse of the isosceles triangle theorem. If two angles of a triangle are congruent, so in this case you can see we're not starting with sides anymore, we're starting with the angles. So angle A and angle B, if they are congruent, then the sides opposite those angles are congruent. So opposite of angle A is actually side BC. Opposite of angle B is side AC. And that's why we can conclude that AC and BC are congruent. So in short, this means if you actually know the angles are congruent, then you know the sides are congruent. So that's why you can see they're kind of going back and forth with each other. That's why this is called a converse of isosceles triangle theorem. So it's going to be either side, knowing the side you can conclude about angles, or knowing the angles that you can conclude about the sides. So now let's practice with some statements. If side HG is congruent with side HK, so side HG is congruent with side HK, so that means you are given the sides. So now you can actually conclude about the angles. The angle that's opposite of a side HG is right here, and the angle opposite of side HK is right here. This angle is actually easier to name. It's just angle G. However, the other angle, the issue here is if you just call it angle K, well, angle K could be this one, could be the one on the right, or could be the whole thing. So in that case, we cannot use a one letter to name an angle. So when you have a point that actually has quite a few different angles, just with that point, you have to use a three-letter convention to name angles. So for example, this angle, I can call that angle B. But I can also call that, let's say you have a point A here and a point C here, I can also call that angle A, B, C. The vertex is going to be the letter in the middle of the three letters. So you start with one side, then go to the vertex, then go to the other side. So in this case, if K is the angle, is the vertex that I want, K is going to be in the middle. And then I can either go HKG or HGK. So I can call that HKG. And to follow the same convention, let's also name the angle G with a three-letter convention. We can call that HGK. There you go. So that's based on the size that we know, we can actually conclude about the angles. Now let's move on. If angle KHJ is right here, and angle KJH is right here, if these two angles are congruent, so now we know the angles, we are going to conclude about the sides. The side that's opposite of KHJ is right here, and that is side KJ. And then the side that's opposite of angle KJH is right here, and that is side HK. So we can conclude KJ is congruent 2HK. You can say KJ is congruent with KH. You can flip the letters around a little bit here and there. That's fine. Moving on. So that means we can actually classify triangles by sides. Scalene triangle is a triangle with exactly 0 congruent legs, or in other words, all sides are different. They just don't have anything being congruent. If they do have exactly 2 congruent legs, that's an isosceles triangle. The reason we say exactly here, technically it's supposed to be at least. But in that case, we can't classify them very clearly. So if you have 2 congruent legs, that's for sure an isosceles. And then when you have exactly 3 congruent legs, that's already a more specific name, which is called equilateral. That's why when it's just 2, we will call that isosceles triangle. That's how we actually separate them. As you can see, there's no such a thing as 1 congruent leg because you can't be congruent with it yourself. So that's why it's just 0 congruent legs, 2 congruent legs, and 3 congruent legs. Now let's move on to some examples. Example 1. These marks on the sides indicate that these two sides are the same, and based on the side to angle, which is the normal isosceles triangle theorem, we know these two angles have to be the same. So this is also an x. 28 plus 2x equals 180. I didn't write the degree symbol because the degree symbol is separate from x. I'm just adding the numbers together. So 2x equals to 152, which means my x is going to be 76. I do not need to include the degree symbol in the answer because x is just a number, degree symbol is taken care of already. Example 2. Start on the right side. These two sides indicate that these two angles are the same, which means the one on the top is also a y. 2y plus 100 is going to be 180. 2y is going to be 80, so y is 40. Next, on the left side, these double marks indicate these two sides are the same. So that makes these two angles being the same. So the one on the top left is going to be 50 degrees. So we have x plus 2 times 50, that equals to 180. So x plus 100 equals 180, which means my x is going to be just 80. There you go. That's example 2. Moving on, example 3. The two marks indicate that these two angles are the same. So the one on the left is also a y. So we have 2y plus x equals 180. However, if you only have one equation with 2 variables, we can't exactly solve them. That's why we also have a relationship right here. 110 degree and the y makes up a straight line. So that's a straight angle. 110 plus y equals 180. So my y is going to be 70. And in that case, that's going to change my equation a bit. X plus 2 times 70 equals 180. X plus 140 equals 180. So my x is going to be just 40. That is example 3. Moving on, example 4. It is asking for 6 different angles, so we might as well just start with a graph and label anything that we can find based on the information that's given in the graph. So we can see ABC, triangle ABC, each side has a little mark on them. That indicates all 3 sides are the same. That means it's an equilateral triangle. So all the angles would just be 60 degrees. If they're 60 degrees, the vertical angle here is also going to be 60 degrees, and that makes the other 2 angles 120 degrees. Okay, and then let's move on to the triangle on the right. So this is 50 degree, but the double mark on the sides, which indicates these 2 angles are the same. Let's say they're both x. So 50 plus 2x equals 180, and 2x is 130. That makes my x a 65. So these 2 angles are just 65 degrees. And if they're 65 degrees, well, this is a straight angle here. That makes the angle on the right, to the right of 65 degree, 115 degrees, because it's going to be 180 minus 65. Right. And then in the middle, 60, 65, and this middle angle together is making up a straight line. So that angle itself is just going to be 180 minus 60 minus 65, which is going to be 55 degrees. Now let's start answering the questions. The measurement of angle BCA, angle BCA right here, well, that's a 60-degree angle. Next, angle DCE is right here. That is a 65-degree angle. DEF, well, it's this one on the outside of the triangle, so it's 115 degree. Angle BCD is the one in the middle we also found, which is 55 degrees. Then angle BAG is the one on the left, so that's 120 degrees. The last one, angle GAH, is right here, which is a 60-degree angle. That is example 4. Moving on, example 5. There are two separate triangles. They're both isosceles triangle, but we're going to start with the one that has a number in it. These two sides indicate that these two angles are the same, so that makes the angle on the right side is a 55 degree. We have x plus 2 times 55, that equals to 180. So x plus 110 equals 180. My x is a 70. If my x is a 70 degree, that makes the vertical angle here a 70 degree. But these two sides are the same, which means the base angles are going to be y. So 2y plus 70 equals 180. 2y is 110. So my y is going to be 55. That is example 5. Moving on, example 6. So find m and n. As you can see, there are basically two triangles. So we're going to start with the smaller one because m is an angle in between the two triangles. So I'll find that later. I'll start with the triangle, the smaller one. Smaller one has a right angle, and then these two are both being double marked. Then we have an n, which means because of double mark, that tells you both base angles are the same. So the top one is also an n. 90 plus 2n equals 180. So my n, 2n is 90, which makes my n a 45-degree angle. Okay, next. Then we have this angle right here. Well, we're focusing on triangles. So now let's actually look at the bigger triangle. Even though that does not give us directly m, it still gives us some relationships. So these two marks indicates that these two bigger angles are exactly the same. So we can find the bigger angle, then we just need to subtract the n. That's going to give us the m. So that's 50 degrees. Let's say these two angles are both x. Then 50 plus 2x equals 180. So 2x equals 130, which makes my x a 65-degree angle. And m is the 65 subtracting the n, which is my n is actually 45. So that makes the m a 20-degree angle. But this is, of course, is not the only way. Here's another way, for example. If this is 90 degree and the full circle is 360, that makes the other side a 270-degree angle. We have 270 plus 50. So I'm actually focusing on this little boomerang kind of shape. It's a four-sided shape, and if this side is an m, the other side is also an m, so plus 2m inside a four-sided shape is 360 degree. So that's another way to actually solve for m, which is also going to give us a 20. So I'm just giving you another solution for this, but there might also be other ways that you can try. That's the last example, and that is everything for isosceles and equilateral triangle lesson. Thank you.